Bad Qrels make good rankers look bad. Pooling with PyTerrier gives you a cleaner way to build evaluation labels from multiple retrieval runs. This is the workflow you'll know how to run when we're done, which blends multiple retriever rankings into pooled relevance labels. I'm Professor Pi, teaching search and IR with simple Python. Label noise and missing judgments sabotage experiments more than most people expect. You run a retriever, and it returns sensible documents. But the official Qrels can still miss many of them. That gap makes a model appear weaker than it really is. Pooling fixes this by collecting candidates from several systems and asking judges to label only that combined shortlist. PyTerrier fits neatly because it handles retrieval and run merging with familiar DataFrame operations, so you don't have to build that plumbing yourself. Think of pooling as auditioning multiple rankers and keeping any document that any of them liked. The win is better coverage of the actual candidates at your evaluation depth. Even a modest pool depth often raises recall on positives and makes metrics more trustworthy. The trade-off is extra annotation work, but it's focused work and far smaller than labeling whole collections. We will build a small toy pipeline on the Vaswani dataset. First, we seed a BM25 run to produce baseline candidates. Then we synthesize 2 variant runs to stress the pool and create new doc IDs. We merge the runs, rank pooled candidates by consensus and rank, mark which are unjudged, and then heuristically label some of them so you can see how enriched Qrels change evaluation numbers. The goal is to keep the example concrete and the code targeted on the idea, not on infrastructure. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. We need a simple, seeded run to anchor the pool and ensure deterministic doc identifiers. This snippet initializes PyTerrier on the Vaswani collection and produces a compact BM25 run for pooling. The guard around pt.started avoids clashing when pt.init gets called multiple times in the same notebook. We grab the dataset handle so batch retrieve can focus just on wmodel equals BM25 without extra wiring. Asking for only 5 results per query keeps this example tight while still giving us a rank data frame with QID, docno, score, and an explicit rank column. Assigning ranks with group by makes the positions deterministic, so later pooling and merges reuse the same order. The printed doc identifier is a quick check that the BM25 seed produced a concrete candidate to include in the pool. The BM25 baseline gives us structure, but we need alternative preferences to grow the candidate set. This example reshapes the BM25 data frame into proxy splayed and dense outputs that introduce a fresh candidate. We load Qrels early, so every later merge with manual labels points to the same judged frame. Reordering BM25 run with ilock mimics splayd's different ranking, while copying keeps the synthetic run independent of the baseline. Reversing the dense run deliberately surfaces pool 1 at rank 1, creating an unjudged document that stresses the pool without inventing scores outside PyTerrier schema. Recomputing ranks preserves Trek-style ordering, so downstream group bys don't misread stale positions. The printed count tells you how many new documents the synthetic dense variant contributes beyond the judged set. Now we need to merge these runs to see which documents multiple systems agree on. This code unifies the 3 runs and derives pooling signals like hit counts and best ranks. pd.concat stacks the rows, while assign, model, name keeps track of each run's origin. Grouping on Seaweed and DocNo surfaces how many systems saw each document, alongside the earliest rank and the strongest score. The classic heuristics used for depth K pooling. Sorting by hit count before best rank pushes consensus documents up, while still honoring early placements from a single run. Because the frame stays keyed by QID, this approach scales naturally to more queries and more systems. The printed size confirms how many unique documents will enter the shared judgment pool. With a pooled candidate list, we can compare it against the Vaswani Qrels and find gaps. This snippet merges pooled candidates with existing Vaswani Qrels, so we can prioritize what still lacks labels. The merge brings the Qrels label column alongside hit count, so judged and unjudged docs are easy to spot. Filling missing labels with -1 creates an explicit sentinel that downstream logic treats differently from genuine 0 grades. The priority formula multiplies hit count and subtracts best rank, which promotes documents seen often and early across runs. Sorting first by label and then by priority ensures unjudged items bubble to the top while keeping a deterministic order for ties. The printed value reports how many entries in the top 5 remain awaiting assessment. Finally, we simulate simple annotation for the unjudged items and measure the effect on evaluation. This example orchestrates heuristic labeling of unjudged docs and evaluates the impact via PyTerrier experiment. We isolate rows marked -1, so the manual DataFrame mirrors only the pooled candidates that need judgments. A straightforward threshold on max score emulates annotator decisions, and dropping the score column leaves a clean Qrels-like table. Concatenating with the original Qrels and collapsing by per doc maxima preserves any existing positives while folding in the new labels. Recall at 5 plugs into pt.Experiment, letting us evaluate the cached BM25 run DataFrame as if it were a pipeline output. The printed recall summarizes how the enriched Qrels change BM25 coverage at depth 5. If you mapped this to a real project, you would export the top pooled candidates per query to an annotation tool. Judges review a concise shortlist per query, and their labels merge back into your Qrels table. That loop gives you richer evaluation labels without mass annotation and helps keep experiments honest. Pooling with PyTerrier means collecting candidates from several systems into one judgment pool. Use it when Qrels miss plausible documents and you want fairer evaluation. The trade-off is more annotation, so pick a priority rule that focuses effort rather than overwhelming reviewers. Next step, tune BM25 T1 and B in the seed run, and observe how different baselines change the pool composition and final recall. If short, practical IR helps, subscribe and watch the IR videos.